Good morning to everyone. Let us see hydraulic motors. The main objective of this PPT is what is hydraulic motor, what is the difference between hydraulic motors and a hydraulic pump, and what is the difference between hydraulic motor and a electric motor. List the various applications of hydraulic motor in fluid power and classification of hydraulic motor. The last objective is the construction and working of gear motor. What is hydraulic motor? Hydraulic motors are rotary actuator. The definition of hydraulic motor is a device which converts fluid power into rotary power or converts fluid pressure into torque. We should know the difference between hydraulic motor and a hydraulic pump. Hydraulic motor is a device for delivering torque at a given pressure, but hydraulic pump is a device for delivering flow at a given pressure. Motors as usually operate over a wide range of speed from a low RPM to high RPM, but pumps usually operate at a high RPM. Most motors are designed for bidirectional applications, but pumps usually operate in one direction. Motors are subjected to high side loads, but pumps are not subjected to side loads. Motors may be idle for a long time, but pumps usually operate continuously. Next, we will see the comparison between hydraulic motor and an electric motor. In the electric motor, they cannot be stopped instantly. The direction of rotation cannot be reversed instantly. This is because of air gap between the rotor and a stator and the weak magnetic field. But hydraulic motor can be stalled for any length of time. Their direction of rotation can be instantly reversed and the rotational speed can be infinitely varied without affecting the torque. They can be brake instantly and have immense torque capabilities. Electric motors are heavy and bulky, but hydraulic motors are very compact compared to electric motors. For same power, they occupy about 20% of space required by electric motors and weight about 10% of electric motor. In electric motor, moment of inertia to torque ratio is nearly 100, but in hydraulic motor, moment of inertia to torque ratio is nearly 1. Applications of hydraulic motor. It is used in wide range of applications. They are metal handling equipment used in metal handling equipment, railway locomotives, buses and machine tools, road machinery, numerical control machines, and high performance aircraft. Classification of hydraulic motors. Hydraulic motors can be classified as follows. Depending upon the mechanism employed to provide soft rotation, hydraulic motor can be classified as follows. First one is gear motor, second one is van motor, third one is piston motors. Motors further classified into two types, axial piston type motors and radial piston type motors. Now we will see the construction working of gear motors. A gear motors develops torques due to hydraulic pressure acting against the area of one tooth. There are two teeth trying to move the rotor in the proper direction, while one knit tooth at the center mesh tries to move in its opposite direction. The design of gear motor, one of the gears is keyed to an output shaft, while the other is simply an idle gear. Here any one of the gear is connected to output shaft, another one is a follower. The pressurized oil is sent to the inlet port of the motor. The pressure is then applied to the gear tooth, causing the gears and output shaft to rotate. The pressure builds until enough torque is generated to rotate the output shaft against the load. The side load on the motor bearing is quite high because all the hydraulic pressure is on one side. Here the oil is entered into the inside of the motor, then it is trapped between the tooth and casing, then then drawn into the outlet port. The pressure of the oil rotates the motor. In hydraulic gear motor, the output power is calculated from the formula 2 by nt divided by 60. That's all. Thank you.